Welcome to Chemistry 2, Unit 2 Thermochemistry. This will be Lesson 2, Video 1, and this is on heat transfer. So anytime we have two objects that are a different heat, heat is going to be transferred from one object to another. So heat flows from one object to another. And it goes from the hotter one to the colder one. So it's a transfer. But the thing that we have to remember is that heat lost is equal to heat gained. A lot of times this is referred to as efficiency. Heat is a form of energy, so the energy loss must be gained somewhere. Heat is the most disorganized form of energy. So we know that we can calculate the heat that something contains by using the specific heat equation, Q equals mc delta T. So if we have Q is equal to mc delta T for the object that is losing heat, and we have Q is equal to mc delta T for the object that is gaining heat, since the amount of heat is equal to one another, these two equations are going to be equal to one another. So this one's going to be for the substance losing heat, and this is for the substance gaining heat. Now, because we are going to have some errors with signs in this case, we know that the values for Q of anything that's losing heat is going to be negative. For anything gaining is going to be positive. And it's a delta T that gives us the positive and negative. I'm going to put absolute value signs around the delta T so we don't end up with sign errors. So let's look at this example. We have a piece of nickel metal at a temperature. We place it into water at a given temperature, and the temperature of the system reaches 25.4. We're going to be looking for the experimental value of C for nickel and the percent error. So here we have the temperature of the system, and all the problems that we're going to do are like this one. And we're going to do a lab on this. So this temperature of the system is T sub F for both substances. So they reach a middle ground. So they reach the same temperature. So the metal was at 650, it's going to 25.4. The water was at 22, it's rising to 25.4. So we're going to set this up. MC delta T, absolute value, is equal to MC absolute value delta T. So this is going to be for nickel, and this is going to be for water. So all we have to do is put in our values. The mass of nickel is 6.50 grams. We're looking for C for nickel, and the absolute value, our final temperature for the metal was 25.4, and our initial was 650.0. The mass of water is 150.0 grams. C for water is 4.18 joules per gram degree Celsius. You need to know that value. And then the absolute value, the temperature change, the final temperature 25.4 and initial was 22.0. So this is a little bit more complex of an algebra problem. So you should be able to solve this for C. Do the absolute values, solve for this side, and divide by these values here. And you should get an experimental value for C for nickel to equal 0.525 joules per gram degree Celsius. So that's one of our answers. So it's asking us for our percent error. So we need to know what the actual value is. That's where our chart comes in. It should be 0.4442 joules per gram degree Celsius. So if you recall, percent error was experimental minus actual all over actual times 100. So 0.525 minus 0.4442 all over 0.4442 quantity times 100 will give us an 18.2% experimental error. So now you can complete worksheet on heat transfer.